This is the lesson from September 9th. Today we began talking about writing our own definitions. You got a geometry dictionary that you're going to have for the whole semester, and the pages are alphabetical, and each word you have 4 spaces. One for the word, one for the definition, the formal mathematical definition, and then one for your own definition, so you're going to write it in your own terms. I expect you to fill it in, but I expect that it's just there's no correct answer for this. It's just your way of remembering the word. And then a picture and an example of how you would use it. So to start off, our first word for geometry on the page that starts with a P is point. So go ahead and fill in. I didn't fill it in this grid system. I just filled it in on this packet. So the first term is a point. All it is a location. It has no size, and in your picture, it's the easiest picture you're going to have to draw, is just a little dot, and denote it with a capital letter. You can use any capital letter. This one we just called point P. So instead of actually saying point P, you could literally just draw a dot and a P, and that means point P. The next one, now that we have the definition of a point, we can define line. So a line, a lot of people don't realize this, but all that a line is a straight arrangement of infinitely many points. So what that means is along this line, all that it consists of is, I'm having a hard time using my mouse, is all of these little points. There's infinitely many points here. That's what actually creates that line. I think a lot of people don't realize that. So a line goes on and on and on forever and ever in both directions. It has infinite length. To name this line right here, you only need 2 points. You could, if there were 3 points, that's fine, but you only need, let's say this is the letter C. You could call this then line AB, or you could call this line CB, or you could call it line AC. It doesn't actually matter. Goodness. So we could, and then you need to denote above so that the reader knows that this is a line. Make the line symbol above. So this could be line CB. Just like this. And then the line symbol above. Okay. So now, next we have a plane. A plane is just a flat surface. It extends in all directions. It has no thickness. So my way of thinking of it is like a piece of paper or a football field that goes on and on forever and ever. You usually denote it with a cursive letter P, and you can either call it just plain P with your cursive letter, or you can have 3 points because you need a minimum of 3 points to name a plane, and that would be, you could just call it plane ABC. So now moving on from that, we've got collinear. Collinear, if you break this into 2 parts, we've got co, and then we've got linear. When I think of linear, I think of a line. So, and co, I think of my coworkers. Who do I work with? We're on the same job, right? So the same, collinear is going to mean on the same line. So points on the same line is collinear. So if I look at this picture, we've got a line. A, B, and C, all 3 of these points are on the same line. But D is not collinear with A, B, and C. So then coplanar, it's going to be a shock. It's just on the same plane, objects on the same plane. So you can have points on the same plane, or you can have lines on the same plane. So this line and this line are on that same flat surface. So those are all of those. You could have lines or points that are on the same plane. then a line segment. We know it's part of a line, but it's marked by 2 endpoints. So it's 2 endpoints and all of the points in between. So there's a bunch of little dots here, a bunch of points, infinitely many points between these 2 endpoints. And we name it by the endpoint. So it would be segment OK. Or you could say KO. KO. Either one is just as correct. And again, just so the reader knows, this is our geometry code. The reader knows there's a line segment above it. And then the endpoints, those are just the points on the end. So here O is an endpoint and K is an endpoint. Moving right along. We've got congruent. Congruent is like the magic geometry symbol and word. I always joke, when in doubt, guess congruent. So congruent, here's the abbreviation for all of us lazy mathematicians that don't like to draw it or write out the whole word. We can just draw this symbol, like a squiggly with an equal sign. Congruent means it's the same size and the same shape. So if I want to show that 2 segments are the same size, I need to draw my segment, and then I need to have the same number of hash marks on each segment. So if this one has 1 hash mark, I need to draw 1 other hash mark on my segment CD. If I had another figure, let's say I'm going to choose a shape. Let's just choose this diamond. If I wanted to say that this segment is congruent to this segment, and then these 2 legs right here are also congruent but different than the other, then I can do 2 hash marks on this one, and since it's the same length here, I would do 2 hash marks. Again, if I wanted to show that 2 angles were congruent, I would mark my angle. So I'd make a little arc, and I could do 1 hash mark here, not hashtag, I'm thinking Twitter, and another angle mark, 1 hash mark right there, and then these angles are the same as well. But it's different measure than these 2, so I'll do 2 hash marks, 1, 2, and 1, 2. Okay, now our next term is a ray. A ray is part of a line extending forever in one direction. So if I think of a ray, I think of like the sun. It starts at the sun. Here's the sun right here, point A. And then the ray comes out of the sun. It goes on in one direction. So to name a ray, you'd always need to start at the origin or original point, point A. And then you'd need to draw, you can choose any point. Remember, there's infinitely many points along this line. So I could say this is ray AB. Or I could say it's ray AC. Okay, now we have a term bisects. Bisects means it divides it into 2 equal parts. Bi means 2. Sect, means a part or a section. So it's 2 equal sections. So I can see here that point M bisects XM and YM. Or point M bisects X segment XY. Or you could say line NM bisects the entire segment XY. Or look here, we can say, oh look, here's this angle X. Ray XP bisects, because it cuts it into 2 equal angles, I see by those congruent markings, bisects angle X. Now there's just a few examples we can go over. It says, name each midpoint and the segment it bisects. So if I look, I can't assume anything unless there are markings. So if there's congruent markings or there's measurements. So if F is the midpoint of CD, that's actually true because CF is the same length as DF. So therefore, those are congruent. So I can say F is the midpoint of CD. I cannot say F is the midpoint of EG because there are no measurements here. You cannot assume anything. Then how about over on this triangle? The only midpoint I can say is K is the midpoint of segment JL. Now on this one, there's no information. There's no measurements, no congruent markings. I can't assume anything. And then here it says name all of the congruent segments. Use the congruent symbol to write your answers. So we know CF, segment CF, note the symbol, is congruent to segment FD. Here we can say JK is congruent to KL. So that concludes September 9th's lesson on the building blocks of geometry. You can work on page 8 in your homework packet. It's titled 9-9. And then you can finish your own personalized definitions in this box on your vocabulary packet.